Your second section for this week is all about subsets. So a subset is just if I take a set, my collection of things, and then I'm talking about a few less of those things. So we have very specific math definitions here. So if A is a subset of B, you can write it like this. Now look at this symbol. It looks a lot like this guy. This guy means less than or equal to, meaning that you're smaller than or including that number. Remember, we were talking about numbers in our sets last time from natural numbers. This guy means the same thing, but just about collections. So if A is a subset of B, that means that every element in set A is also in set B. So if I'm in A, then I have to be in B. But it doesn't mean that everybody in B can be inside A. So you can think about these two sets as being like buckets or cups of things. And if I have a whole bucket full of like the letters of the alphabet, and then I scoop out some of those and put them in another bucket, this is going to be a subset of this one because I got it from this set right here. Then we have a proper subset. So a proper subset means that everybody in A is also in B, but they can't be equal. So up here, they're allowed to be equal. Down here, they're not allowed to be equal. So a proper subset means everything in A is also in B, but there's more things in B than there are in A. This one means either way. Either A and B have the same number of things or they don't, but everything in A is also in set B. So this little line underneath means they could be equal or they could not be equal. This one without the line means they absolutely cannot be equal. Just everything in A has to be in set B. So then this little guy, if it has a line through it, means that A is not a subset of B. So anytime you see a math symbol with a line through it, it just usually means is not. So this guy means A is not a subset of B. What is that? A subset of B. So that means there's at least one element in A that's not an element of set B. It could just be one, it could be lots. But if any single person in A is not in B, then they're not, A is not a subset of B. So we are going to use these symbols to talk about these sets. So here I have A is 1, 3, 5, and 7. B is 1, 3, 5, 7, and also 9, and also 11. So you can write this guy or this guy in the blank to make it true. So if I'm going to write this one, that means that every single number over here I can also find over here. So I have a 1, I can find a 1. I have a 3, I can find a 3. 5 and 7, I also found those. So this is a true statement. A is a subset of B because everything that's in this set right here, I can also find in this set. Okay, oh, we got some set builder. So X such that X is a letter in the word proof. So P, R, O, and F. If I was going to make a roster notation, I would do P, R, O, F. If you're doing roster notation, you don't write things twice. If you see it twice, you only write it once. Okay, and then set B is a letter in the word roof. So I'm going to use roster notation R, O, and F. So I need to decide if A is a subset of B. So that means, can I find all of these letters in this set over here? Can I find a P over here? I cannot. So that means that A is not a subset of B because there's a letter in A, there's an element in this set that is not in this set over here. But this one is a subset of this one. So you could write that B is a subset of A. This is true, but this is also true because A is not a subset of B. Now this one, you're going to practice writing both. So remember, if it has like the equal to, that means they can have the exact same things in both set A and set B. If it's just this one, it means A is strictly smaller than B. So let's look at this one. I have X is such that X is a person and they live in San Francisco. And then this set is a person that lives in California. So you need to ask yourself first, do all the people that live in San Francisco and all the people that live in California, are the numbers of people the same? Like if I go look and say how many people live in San Francisco and it tells me 5 million, I have no idea. And then how many people live in California, am I going to get the same number in both of those sets? I'm not. There's more people that live in California than live in San Francisco. So that means that this symbol is out of contention. We can't use this symbol for this set right here because they don't have the same number of elements. And then you need to decide, if I talk about one person in this set, one person that lives in San Francisco, is that person also living in California? And that is true. So that means A is a proper subset of B. So everybody in set A, every single person that lives in San Francisco, is also in set B. They also are living in California. But I can't put the equals little line underneath because there's different numbers of people that live in San Francisco and numbers of people that live in California. Okay, let's look at this next one. So I have 2, 4, 6, 8. That's a 4. And then I have 2, 8, 4, 6. So first, let's see. I have 4 elements in this set. I have 4 elements of this set. Remember, that's the cardinality. And then, can I find all of the numbers in A? Can I also find them in B? Can I find 2, 4, and 6, 8 over here? And you can, 2, 4, 6, 8. Remember, in roster notation, the order doesn't matter. So the symbol that we can put here is we can use this one because everybody in A is also in B, and also they have the exact same number of elements. And you can also say A is a proper subset of B. Nope, you can't say that because they have the same number of elements. Okay, let's go to the next page. Okay, let's go back to this one. So right here, I have A is a subset, a proper subset of B, because there's less people that live in San Francisco than there are that live in California. You can also say A is just a subset of B, because that means that every element in A is also in B. And I have satisfied that. I can find everybody that lives in San Francisco is also living in California, so I can use this symbol. And then I can use this symbol because they have different numbers of people in their sets right here. So on your math lab assignment, you would choose this one and this one. You'll choose both of those symbols on this math lab assignment. Okay, on this one, you've got 2, 4, 6, 8, 2, 8, 4, 6. So right off the bat, this has 4 elements and this has 4 elements. So they have equal elements. So I'm not allowed to use this symbol because this symbol is only when A and B are not equal. So now we need to see, can I find 2, 4, and 6, and 8 over here? And you can. You can find 2, 4, 6, 8. Remember, in roster notation, the order doesn't matter. So you could say that A is a proper subset of B, which is what I have here. And then I messed up some other stuff here earlier. Let's go to the next page. All right. We got to talk about the empty set again. So for any set in the entire world B, the empty set is a subset of B because there's nothing in the empty set. So I can go and find that in B. If I have like a bucket of seashells and I ask you to pick some out, you could choose to not pick any out of the bucket is kind of how you can think about it. So for any set B with elements in it, the empty set is a subset of B. And then if B is not the empty set, then it's a proper subset. Because obviously, if there's nothing in this set at all, that's going to have less elements than any other set in the world with something in it. So we are going to figure out how many subsets there are for any given set. So we're going to list all the subsets of this set. So I've got dog and cat and fish. So a subset is just pieces of the original set, remember? So if I have a dog and a cat and a fish in what's humane, a box, and I ask you to just pick out some groups of things. You could pick out a dog, you could pick out a cat, or you could pick out a fish. You could pick out a dog and a cat together, or a dog and a fish together. You could pick out a cat and a fish together. If you pick out a cat and a dog, well, we've already talked about that possibility right here. And then you could do a fish and a dog, which I have right here, and a fish and a cat, which I have right here. Or you could pick out all 3. You could pick out a dog and a cat and a fish. You could pick out all 3. And then also remember that the empty set is a subset. So here's all of my subsets. So whenever it asks you to list them all in MATLAB, this is what it's wanting. So here's all my subsets here. And if you look, there's 1, 2, 3, 4, 5, 6, 7, 8 of them. There's 8 subsets. But what if I gave you a bigger set? What if I gave you a set with like 10 things in it and I said, how many subsets are there? That would be really annoying to write down all these possibilities. So there is a formula. So to find the number of subsets of a given set, first, you find the cardinality. So we'll call it N, because remember earlier I said like N of A and N of B. So find the cardinality of your set, how many elements there are. Write that down. How many elements are in your set? And then you use the formula subsets equal 2 to the n. And this little n up here is an exponent. So that means this little n is like a teeny little number. And an exponent up here means that you're going to do repeated multiplication of this number down here, which is 2. But I'll also show you how to use your calculator to do that. All right. So you remember that every subset or every set is a subset of itself. So if you look up here, whenever we listed it, I also listed dog and cat and fish. So if I'm asking you how many proper subsets there will be, meaning sets that have less elements than the original, you'll do 2 to the n minus 1. So whatever you get, you'll just take off the 1 that has every single element in it. So we are going to find our numbers of subsets. So this is the first time you're going to need your calculator. I told you in the intro to go buy this Casio one. It's worth the extra $1. I promise. I promise it's worth it. So here's my set. I have 1, 2, 3, 4, 5 elements in this set. So that's the first thing you need to find is how many elements. I need to find the number of subsets and the number of proper subsets. So subsets equals 2 to the 5th. So we need to figure out 2 to the 5th. Now what this means is it means that you're doing 2 times 2 times 2 times 2 times 2. So you'll multiply 2 by itself 5 times. That's what that means. But you do not have to figure this out in your head. You do not have to write out this. Whenever you're doing your group assignments and your written assignments, I need to see this so that I know that you know what to do. And then I'm expecting you to put this in your calculator and get your answer for it there. So let's look at our calculator. If you have this Casio calculator right here, there's an exponent button right here. Do you see it says X? Here, I'll get something that's a different color. I'll get pink. So it has this X right here, and then it has that little like square up top. That square means that you're going to put an exponent on there. So on this calculator, what you'll do is you'll type in 2, and then you'll hit this button right here, and it'll pop up a little square up here, like up top where the exponents go. And so we can put our 5 just right in here. And then you'll just hit your equals button down here, and you should get 32. Yay, we got 32. So that's how many subsets this set has. If you have the TI calculator, then what you're going to do is you're going to go look on your TI calculator for a caret button. It looks like this. And in your calculator, you'll type 2 and then like a caret button and then 5. It'll look like this, and then hit the equal sign, and it'll also give you 32. So this set has 32 subsets. I'm going to put TI calculator right here for you guys. And then if I ask you how many proper subsets, you'll just do 32 minus 1. So proper subsets will be 32 minus 1, so there's 31 proper subsets. Okay, let's look at this one. I have a set builder notation. I want natural numbers between 9 and 15. Ask yourself, am I including 9 and am I including 15? Yes, I am. So if you want to, you could list them out. This is 9, 10, 11, 12, 13, 14, and 15. So there's 1, 2, 3, 4, 5, 6, 7 elements. So this is a good chance for you to practice on your own before you like see my answer. So you could pause this video and figure out how many and then hit play and see if you got the same answer that I did. This is good for you to practice on your own. So if you're doing subsets, you'll do 2 to the 7th and put that in your calculator. You should get 128. And then if you're doing proper subsets, you'll do 128 minus 1 and get 127 proper subsets. That's a lot of subsets. So I would never give you 7 elements and ask you to list all of the subsets because that would be 128 different combinations and that would take forever. All right, you guys are done with your first week of material with me. So you should have watched 2 of these videos. You should have done, or well, now you need to go do 2 assignments in Math Lab. You need to do your group assignment together and turn that in, and you need to do your written assignment and turn that in by Saturday. Good luck.